Okay, so last time we briefly started chapter 4, which was about the inverse. Okay, so remember there was this special notation for the inverse, which is this one. Okay, so now the next definition is about the one-to-one. Okay, so f of x is said to be one-to-one, and by the way, that is the official notation of the one-to-one. Okay, so that's not just my notation. Okay, so that is kind of official mathematical representation of one-to-one. Okay, and it's not 1 minus 1. If every x value or x coordinate in the domain corresponds to the exactly one y value in the range. Okay, now this definition may not sound that powerful, but once we get to this informal representation of the one-to-one, it will become clear why this is really powerful. Now, actually, that's not the official definition of the one-to-one that I have learned. Alternately, we can say f of x is one-to-one if f of, say, x1 equals f of x2. Okay, so now what does that mean? x1 and x2 are the inputs, the x values, and you plug them into the function and somehow their outputs are the same. And this implies the input is all the same, or now this is kind of, like logic, but this condition implies this. So the equivalent way of saying this is you negate this, and then that implies the negation of this, which means if the two x values are different, then their outputs must also be different. Okay, so these two things are the same thing. Okay, so now that is kind of the official definition of the one-to-one, but alternately or like informally, this one-to-one-ness means, so remember, I think at some point I had this picture. Oops, something like this. Okay, so now remember, this was okay, right? But this isn't, right? Remember that? Okay, because that's a function, whereas this isn't, right? Now, one-to-one simply means this. Okay, so what do you notice? So, like this is illegal, of course, so that's the worst case. And this one, although it is okay, so this one can still cause some trouble. Okay, now what about this case? So what about this case? This means what? Each guy corresponds to the exactly one girl, so that's kind of the best case, right? Okay, so there's no fight, there's no competition, and it's the kind of best possible case scenario. Okay, anyways, so you can see why the one-to-one is really powerful and the best in some sense. Now, why do we ever need this one-to-one? Because now it's related to the inverse, okay? So several facts, I think there are 5 facts, yes, okay? So now, the first one, if f of x is one-to-one, then f inverse exists, okay? So what does that mean? If f is not one-to-one, there won't be any f inverse, okay? So that is the relation between the inverse and one-to-oneness. Now, fact number 2. So from the past, we have seen that the point a comma b is same thing as the expression f of a equals b. Remember that? Okay, so now pictorially, we can have this representation. Okay, so suppose there are 2 points a and b. Now, to get to b from a, we take the bus, so-called f, okay? Right, because then a is the input and b is the output. Now, the question is, can we come back to A from B? And the answer is yes. Now, the thing is, we cannot take the same bus because this F bus only takes you from A to B, okay? So if you want to come back from B to A, you have to take a different bus. And the name of this bus is F inverse, okay? Because we are coming back to A. Now, from here, when you take the F bus, A was the X value, okay, and B was the Y value, right? Now, when you are coming back, what becomes the input? That, right? Okay, because that's the starting point and that's the ending point. So what does that mean? It's F inverse of B. Okay, so now B is the X value, and that's equal to the final destination, which is A. Okay, so in other words, F of A equals B is same thing as, okay, so what do you notice? You can move this F, which is in front of A, to in front of B, but somehow you have to put an inverse sign, okay, because now your starting point is different. Okay, and now, fact number 3, the domain of F of X is equal to something of its inverse. Okay, so now what goes into the blank? So in between these two functions, they are opposites, right? Okay, so what do you expect? In between domain and this blank, they're also opposite, right? So what's the opposite of the domain, basically?
Range.
Yeah, the range, right? Yes. Okay. So the domain of one function is same thing as range of its inverse. Okay. Now, can we swap domain and range? Okay, so now what does that mean? What about the range of F of X? That will be the same thing as, okay, so now let me go to the next page. So the range of F of X is same thing as the domain of its inverse. Okay, so basically fact number 3 and 4 are related. Okay, so range and domain are opposites in terms of the F and F inverse. Okay, and now fact number 5, the last one. When you graph F of X and its inverse at the same time on the same XY plane, they will be symmetric in terms of the line y equals x. Okay, in terms of the line y equals x. And what's the reason? Okay, so basically the reason is, remember earlier, or by earlier I mean from previous class, we had that f and g are inverses if the composition of f and g is same thing as the original value x, and when you swap f and g, you also get the same thing back. Remember that? Okay, so now basically where you start is same thing as where you end. So which equation gives you input equals the output? That is the only case, right? Okay, because that says no matter what you plug into x, y is the same thing, right? Okay, so what does that mean? Y equals x passes through the origin. Okay, so whatever you sketch, like whichever is the graph, like for example, something like this maybe. So suppose this is the graph of f of x. Then how does the f inverse graph look like? Just reflected in terms of this line, right? Because they're supposed to be symmetric in terms of y equals x, okay? So that is the powerful thing about this last fact. Okay, so again, just to fill in the blank, if the graph of f of x is given, and we know f of x is 1-to-1, okay, then what does that mean? F inverse exists. So we can just flip the graph over y equals x. Okay. Now, is there any way to tell whether the function is one-to-one based on the graph? Okay, based on the graph. And here comes another test called horizontal line test. Now, in section 2.3, I believe, we saw vertical line test. And remember that test was used for telling whether something is a function or not, right? Okay. Now, horizontal line test. So basically, the statement is nearly identical. So suppose there is a horizontal line through the graph, okay, that meets the graph at more than one point. Now, if you replace this horizontal part by vertical part, what's the conclusion? If there's a vertical line through the graph that meets the graph at more than one point, it's not a function, right? Okay. Now, what about this case? The conclusion is your f of x is not one-to-one. Okay. And now, what does this imply? What if the horizontal line passes the graph at exactly one point? Then this implies f of x is one-to-one. Okay. So again, by reiterating what I just said a minute ago, for the vertical line test, it's used whether the graph is a function or not. Okay, so there's a difference here. Now, does that mean the graph that we use the horizontal line test, does it already pass the vertical line test? And the answer is yes, it does. And how do we know it? It says f of x, right? And what does that mean? That's a function. Okay, so assuming the function means what? The graph already passes the vertical line test, right? Okay, because if not, then we cannot use this function notation, right? Okay, so that's that. Now, here is the scheme to find the equation of f inverse algebraically, assuming f of x is one-to-one. And you can see that there are 4 steps. Okay, now, 3 of these steps are so basic that even 4-year-old kid can know how to do it. Now, you can try it to your cousin or something, or maybe your kids, but it's really basic, basically. Only one of them is not so basic, okay? So, step number 1, there will be the f of x notation, so you just simply have to replace f of x by y. Both are the same thing, so you can do this replacement. And now, step number 2, literally swap x and y. Okay, so basically steps 1 and 2 can be done by a kid, okay, 5-year-old kid, because they know how to do it. Now, step number 3 is the main thing. Isolate y by itself. And that's not so basic. And if a 5-year-old kid knows how to do this, then he or she may have to go to college straight. Yeah, because most 5-year-old kid will not even know what this even means. But if just in case someone knows it, then yeah, he or she has to go to maybe high school or college straight. Just skip preschool, kindergarten, elementary school, and middle school. Yeah. Okay, and then step number 4, replace y by the inverse notation f inverse. Another basic scheme, okay? So steps 1, 2, and 4 are basic. Step 3 is the main thing here. Okay, so now, let's apply all of these to the problems, okay? So, determine whether each function is one-to-one. If so, find the equation for the f inverse. Okay, now part A. We have seen this kind of representation before. Remember that? Okay, so what does this mean? There are a bunch of points and they're contained in a set or group, right? Okay, so what does that mean? This is a relation, remember? Okay, so now, how do we know that this relation is one-to-one? Okay, so let's see. Let me go back to where we started in today's class. So the function is one-to-one if what? Every x value corresponds to the exactly one y value, right? Okay, now, do we have it here? Yes. Do you see why? Because you can translate this relation into a picture that looks like this. Okay, so here is the x group and y group. Now, the first point, -2, 8, that means this, right? Okay, and then the second point, -1, 1, and then third point, fourth point, and the last point. So we have this little arrow thing, right? Okay, now remember, what cannot happen is something like this, right? Okay, that's not one-to-one, but what about this? It is one-to-one, right? Because each x value corresponds to the exactly one y value, and we just have one arrow each, right? And remember that corresponds to what? This perfect possible case, right? Okay, so yes, it is one-to-one. Okay, now, how do we find the equation for the F inverse? Okay, so now the thing is we cannot use this scheme here because that's only for what? The function, right? The function equation. But here it's the relation, so what do we have to do? Okay, so if you remember, okay, so now going back to all the way at the beginning of this section. So how do you find the inverse relation? You have to swap coordinates. Remember that? Okay, so what do you have to do here? To find the F inverse, you have to swap coordinates. Okay, so now what does that mean? What does that mean? So swap coordinates. So for the -2, -8, when you swap it, you get -8, -2, right? Okay, and now the second point, even if you swap the two negative ones, you get the same thing, right? But the meaning of this point is different, right? Do you see that? Because from here, that's the x value and that's the y value, right? Okay, but now here, that is the y value for f and that's the x value for f, right? Okay, so the meaning is different, but still we get the same point. Okay, and then 0, 0, 1, 1, and then 8, 2, right? Okay, so that is the equation of the inverse relation f. Okay. Okay, so can I go to the next page? Okay, so now part B. Part B. F of x is equal to 4x minus 7. Okay, so now, how do we know whether this is one-to-one? So here is my strategy. We will use the graph. Okay, now, hopefully you have seen this kind of equation before because this is same thing as what? Y equals 4x minus 7, right? Which is essentially same thing as what? Y equals mx plus b, right? Okay, so now, where have you seen y equals mx plus b before? Its graph is what?
It's a linear equation.
Right, it's a line, right? Yeah, okay. So the graph will be like this, right? Okay, now how do we know that the line is increasing like this but not decreasing? Because
it's not negative.
Right, the slope is positive, right? Okay, so that's why we know it's this one, right? Okay, not this, right? Okay, so now, why do we want to use the graph? Because have we seen something that we can tell whether something is one-to-one using the graph? And the answer is yes, right? The horizontal line test. So does this line pass the horizontal line test? Yeah, right? Yeah, because like no matter which horizontal line you draw, it passes the graph at exactly 1 point, right? Okay, so yes, because of the horizontal line test. Okay, so basically, if we are given a function equation, we will use the horizontal line test. Okay, and now find f inverse. Okay, so now we'll find f inverse. Oops, f inverse. So now, how do we find the equation of f inverse? So remember, now we have to use these steps, right? Replace f of x by y, swap x and y, and so on. Okay. So first we have what? Y equals 4x minus 7. Okay, so it's pretty easy. Okay, and now step number 2, swap x and y. So now when people think swap x and y, they tend to write 4x equals y minus 7 like this. Okay, but no, you literally swap x and y. Remember what 5-year-old kid can even think of. Okay, yeah, he or she cannot think, okay, so swap 4x and y. He or she will just swap x and y like this. You literally swap x and y. Okay, and then you isolate y. Okay, so there are 2 steps that need to be done to isolate y. What is the first step and what's the last one?
Add 7 and divide by 4.
Add 7 and divide by 4, right? Yes. Okay, so first add 7, so that means x plus 7 equals 4y. And then divide by 4, so that means x plus 7 all over 4 equals y, right? Okay, so we have isolated y, and then the last step, replace y by its inverse notation. So f inverse of x is equal to x plus 7 all over 4. Okay, now this is fine, but the thing is, we can also rewrite this into 1 over 4x plus 7 over 4, right? Okay, in terms of nx plus b notation. So either this or this. Okay, why am I writing both? Because I'm not sure what NLP will accept. I think it will accept both, but just in case it doesn't accept the first one, it should accept the second one. Okay, so either way. Okay, so that's the equation for the inverse.
On MLP, if those can be simplified, do we simplify them?
Which one? This one?
If it was like 1 over 4x plus 8 over 4, would we simplify?
Yes, then you have to simplify, yes. Yeah. Yeah, in fact, like if that were the answer for like on my exam, I would take off points if anyone doesn't simplify. Yeah, yes. Okay, so now that was B, and then C. X plus 2 quantity square minus 7. Okay, so now let's use the graph. Okay, so let's use the graph. So remember, so this one looks a little bit hard, but notice that this graph is quite similar with the graph of y equals x squared. Do you see why? Because all it does to this function is what? Just add something to x and then you subtract 7 in the back, right? Okay, but the mother function or the original function was this one, right? Okay, and then you kind of do something to it, okay, which we don't know it yet. We'll learn this once we go back to chapter 2. But so have we seen the graph of this x squared before? Yeah, right? How does the graph look like? This, right? Okay, the parabola, right? Okay, now, does it pass horizontal line test? No, right? Because if you draw this horizontal line, it passes the graph at exactly 2 points, right? Okay, so now what do you notice? It's no. Okay, it's not one-to-one, right? Okay, so now, do we have to find the equation of f inverse? And the answer is no. And what's the reason? Because remember, we had this crucial fact earlier. If f is one-to-one, then f inverse exists. So what does that mean? If f is not one-to-one, there is no f inverse, right? Okay, so that means f inverse of x does not exist. Okay, because it's not even one-to-one. Okay, so we don't need to find its inverse. Okay, and now part D. Okay, so now part D. So basically D and E are kind of the tricky things here. So now be careful on part D. It's not the square root, right? It's the cube root, right? Okay, so now let's try to use the graph. And here we will use the graph for the cube root of x. Okay, and here we don't have just x. If we have 4x plus 5, yes. So the thing under the root is different, but still the point is we have the cube root. And have we seen the graph of cube root of x before? Okay, we had. And do you remember how the graph looks like?
Is it the one where it's in each quadrant?
Okay, what do you mean by each quadrant? Yes, so there are multiple quadrants, yes, but not all of them.
Opposite.
Okay, yeah, opposite. Okay, now the thing is we have seen this kind of graph, and that's not the cube root, by the way, even though it's kind of opposite. But whenever you are dealing with the cube root or even the cubic thing, it kind of has the S shape or the snake thing, if you remember. Now, the cube root graph looks like this. Okay, so hopefully it may look familiar. Okay, so now, is this one-to-one? Yes, right, because if you draw any horizontal line, it passes the graph at exactly 1 point, right? So it is one-to-one. Okay, so now what does that mean? There will be f inverse, right? Okay, so there will be f inverse. So what do we do first? We'll replace f of x by y. So y equals cube root of 4x plus 5. Okay, which is pretty easy. And then step number 2, swap x and y. So x equals cube root of 4y plus 5, right? Okay, and now the tricky thing here. How do you isolate y? And here there are 3 steps that need to be done to get y by itself. What's the step number 1?
Cube each side.
Cube it, yes. Do you see why? Because somehow you have to remove that cube root thing. And the only way to remove is what? Cube, right? Okay. So cube. So that means x cubed is equal to 4y plus 5. Okay, and then at this point, it's kind of straightforward, right? So now what do you do? Minus 5, right? Okay, so you have x cubed minus 5 equals 4y. And then the next thing, divide by 4, right? So x cubed minus 5 all over 4 equals y. Okay, and then the last one is pretty simple. So f inverse of x is equal to x cubed minus 5 all over 4. Or if you want, or if NLP does not accept this one, which I think it should, but just in case it doesn't, you can just rewrite this into 1/4 x cubed minus 5 over 4. Okay, either way. Okay, so basically what do you notice? The cube root and cube are inverses, right? And yeah, that's kind of expected. Why? Because cube root and cube are kind of opposites, right? So what does that mean? If you start from some kind of cubic function, its inverse will have the cube root, right? Okay, so yeah, it can go opposite direction as well. Okay, and now D. F of x is equal to 1 over x minus 5. Okay, so now this one can be a little bit tricky. But first of all, is this one-to-one? And how do we know it? Let's use the graph. Okay, now, we haven't seen the graph of this 1 over x minus 5, but have we seen something similar? Yes, and it's similar with what? 1 over x, right? Okay, and how does its graph look like?
What I said before.
This one, right? Yes. Okay, yes. So the graph looks like this. Oops. And now, is this one-to-one? In other words, does it pass the horizontal line test? Yes, right? Because if you draw any horizontal line, now the thing is, you have to be a little bit careful, like on this portion here. But the thing is, now of course, like my picture is just terrible. But the thing is, even if you draw a horizontal line through this kind of almost flat portion, it will pass the graph at exactly 1 point. Okay, not according to my picture, but remember my picture is off already. Okay, so yes, it is one-to-one. Okay, and now F inverse. Okay, so here, step number 1 is still pretty easy. Put y equals 1 over x minus 5, right? And step number 2 is also pretty easy. It's x equals 1 over y minus 5, because we have to swap x and y. And now, isolate y. So this one can be tricky here, okay? And it's even trickier than the one before. So here is y in the denominator. What can we do first to isolate y? And usually not many people can answer it right away. So here is my hint. We have a fraction here.
You multiply each side by the bottom to get rid of the fraction.
Right? So first remove the fraction, and that is multiply each side by LCD, which is y minus 5. Okay, yes, indeed. Okay, so that is the first step. So what do we get? X times y minus 5. And then when you multiply y minus 5 here, what do you notice? These two cancel, right? So it's equal to just 1. Okay. And now what's the next step?
FOIL the left side.
Say that again?
FOIL the left side. You have to distribute the x, right?
Okay, okay. So here there are actually two ways, and distributing x is fine, yes. So distribute x. So we get what? Xy minus 5x equals 1, right? Okay. And now what? Here is y that we need to isolate.
Add 5x and divide by x.
Add 5x and divide by x, yes. Okay, so plus 5x, and then we have xy equals 5x plus 1, and then divide by x, so we have y equals 5x plus 1 all over x, right? Okay, now, I said a minute ago that this is one way. What is the alternate way? We can divide by x from here without distributing. Okay, then what does it mean? What does it mean? These two x's cancel, right? So we just have what? Y minus 5 equals 1 over x, right? And then what do you do? Just add 5, right? Okay, so you get this, right? Okay, now here is the issue. Are these the same thing? Okay, they look different, right? Now, I claim that they are the same. How? We can rewrite this into 5x over x plus 1 over x. Split the fraction. And then what happens? These two x's cancel, right? So you get this, right? Okay, so they are indeed the same. Okay, so anyways, what is the final answer then? The final answer is either write this, or you can write 5x plus 1 all over x. Okay, I honestly think NLP will accept either way. There's no way that it shouldn't accept one of the forms, but just in case it doesn't, just try the other one. Okay, yeah, and if it accepts neither form, then maybe you have done something wrong. Yeah, it should accept one of the forms, but I think it will accept both. Okay, so any questions over these problems? Okay, so now the next few problems are not too terrible. So next problem, determine whether each pair of functions that are graphed are inverses. Okay, so basically there will be the graphs given, and we have to say whether they are inverses or not. Okay, so here is part A. Okay, so now you can see that there are 3 graphs here: the blue, red, and dotted. Okay, now let's look at the dotted graph first. Do we know its equation? Yes, it's given, right? Right there. Okay, so the dotted line is y equals x. And now we don't know which is f of x and which is f inverse. I mean, you can say the blue is f of x and the red is f inverse, but it doesn't matter. Are they inverses? Okay, and how do we know it? So was there any fact that can be used to tell whether they are inverses? And what did the previous fact say? The graphs of f of x and its inverse are symmetric in terms of the line y equals x. Remember that? Okay, so in other words, are these two graphs symmetric in terms of this dotted line? Okay, so now what does that mean? To get a red graph, for example, do you have to flip the blue graph over this line? And then do you get the exact overlap? Yeah, right? Because this side goes into where? When you flip it, this one, right? And what about that side? Goes into here, right? So when you flip the blue graph over the dotted line, you get the exact overlap with the red graph, right? Okay, so yes, they are inverses. Okay, in other words, both are symmetric, or they are symmetric in terms of the y equals x, right? And now, part B. Okay, so again, we have y equals x. And now, are they inverses? So in other words, are they symmetric in terms of this y equals x? No, and do you see why? Because if you flip this blue graph over this line, how does the graph look like? Something like this, right? That's what it's supposed to look like. And similarly, if you flip this graph over this, it should look something like this, right? Which it doesn't, okay? So what does that mean? They are not inverses, right? Okay, because these two graphs are not symmetric over this y equals x, right? Okay, so that's why that previous fact was important. Now, here is another application of that fact. Graph f inverse, which is the inverse, graph f inverse of the given one-to-one function below. Okay, so what does that mean? This blue graph is f of x. And now, how can we graph f inverse using this dotted line? And now, have we seen this dotted line before? What does that mean? Y equals x, right? Okay, so here, what's the strategy? So we know that f of x and f inverse are supposed to be symmetric over this line, right? Y equals x. Okay, so what do you have to do? You have to reflect the graph of f of x over the line y equals x. Right, because if we reflect it, the resulting graph and the blue graph will be symmetric in terms of y equals x, right? Okay, so now let's see it a little bit closely. So first of all, this portion here, okay, so this one is moving away from y equals x, right? So when you flip it, how does the graph look like? Something like this, right? Okay, and now the second portion. So now look at this tiny portion here, okay? So now that tiny portion is below the dotted line, right? The y equals x. So when you flip it, where will it go? Something like this, right? Okay, like this little top portion here. Okay, and then the third portion. So now look at this, another tiny portion here, right there. Okay, so when you reflect it over y equals x, it will go something like this, right? Okay, and then the last portion, this one, it's moving away from y equals x. So when you flip it, it will look something like this, right? Okay, so in summary, what's the answer? This one. Okay, so that's the graph of its inverse. Okay, so that is another application of that same fact. And then the last problem of the section is on the last page. Okay, so this problem can be a little bit tricky. The graph of f of x is shown below. Use that to find f inverse of -2. Okay, so now this one, here is -2. Do we plug in -2 and then find where the y value is? So is the answer -3? And what's the reason? F of -2 is -3, but we are trying to find f inverse of -2, right? Okay, so now what's the strategy here? So let's just say f inverse of -2 is equal to, say, a. Okay, where a is a number. Okay, so now what does this imply? This implies, so here is the two values, -2 and a. Okay, and to go from -2 to a, we are taking the f inverse route. Okay, so that's the representation of this expression, right? Okay, now, have we seen this similar picture before? Yeah. Now the question is, can we come back? Okay, and now in order to come back, what do we have to take? The opposite of f inverse, right? And what does that mean? It's f, right? Okay, so what can you deduce? From this f inverse of -2 is a, this is same thing as what? This is same thing as f of a equals -2, right? Okay, so now the starting point is a and the end point is -2. So now what does this imply? -2 becomes what? The x value or the y value?
Why?
The y value, right? Yes. Okay, so now what do we have to do? Find the x value, which is a, right? Where the y value is -2, right? Okay, that's what this expression means, right? F of a equals -2. Find whatever x value so that its y value is -2. So from the graph, what do we have to look at? The -2 does not mean the x value, right? Rather, -2 means what? The y value, right? So what is the x value that corresponds to the y value being -2?
0.
0, yes. Okay, so the answer is equal to 0. Okay, in other words, f of 0 equals -2. Okay, so that implies f inverse of -2 is equal to 0. Okay, so many people say f inverse of -2 is equal to -3 because that's what it says on the graph, but it's actually false, right? Okay, so that -2 represented the y value, not the x value, because we had f inverse. Okay, so any questions over these inverse functions? Okay, so that's the end of 4.1. And now we'll go back to chapter 2, okay, and then we'll do 2.4. Okay, so now this is about linear functions, okay? So we have seen linear function before, so this section shouldn't be too bad. So a linear function has the form f of x equals mx plus b. Okay, now remember that this is same thing as y equals mx plus b. Okay. Okay, so now the m means what? The slope, right? Okay, and now, what does B represent? Hopefully you remember this from your previous math class or something that you have taken in the past.
It's an intercept, isn't it?
Okay, what kind of intercept?
X.
Y. Okay, so it's the y-intercept. Yeah, there are only two intercepts, right? So we have 50% chance of getting it right. Unfortunately, you chose the wrong thing. So B means the y-intercept. And if you remember, any y-intercept has the form 0, comma number. Remember that? Okay, so in other words, the x-coordinate is 0, and then the y value is just whatever the number you have, right? B. Okay, now, the domain and range of, okay, so here I said any, but it's actually false. It's almost every linear function is everything. And what's the reason? There's no square root, there's no rational. Remember, those two were the special cases, right? Okay, now, another remark. If b is equal to 0, so what does that mean? You just have f of x equals mx, right? Okay, and now, this graph passes a special point. And what's the special point?
0, 0.
Origin, right? Yes. Okay, origin, 0, 0. Okay, now, conversely, let's suppose m is equal to 0. Then what do we have? F of x equals b, right? And we say that is the constant function. And what's the reason? Because to find the function value, you will plug in some number to x, right? Like, for example, f of x equals, for example, 2. Now, you're plugging in some number to x, but no matter what that number is, what's the output always? That 2, right? Okay, so because no matter what x is, the output y is always a b. Now, how does its graph look like?
Horizontal line.
Horizontal line, yes. It's a horizontal line. You can kind of take a guess from the word constant, right? Because constant means something that doesn't change. So it has to be a flat line, right? Okay, now the domain is everything. Okay, now is the range everything as well? And the answer is no, because, okay, now remember this kind of horizontal line, and suppose this point is, say, 3. So range is the y value, right? What is the only y value that lies on this line? For example, just 3, right? And nothing else, right? Because there's no graph above 3 or below 3, right? So if that is a b, what is the range? Just a single value b, right? Okay, and we don't even use the interval notation here, right? Because interval notation doesn't even make sense. Why? Because there's only one value in the range, right? There's only one y value. So it's just that. Okay, so that's kind of the special case. Okay, and now the next remark is not something bizarre because we have already seen this scheme before. To graph a linear function, how many points at minimum do we need? 2. Okay, now in most cases, the x-intercept and the y-intercept will work just fine. Okay, now, do you remember how to find these intercepts? So, for the x-intercept, how do you find x-intercept? Set something equal to a value. set what equal to what? Set something equal to 0.
X.
Y. Yeah. Okay. So yeah. So 50-50 chance is not that high, right? You can see that. Okay. So you can just flip a coin, and the chance of getting a head or tail, it's 50%, but it's not that high. Anyways, so set y equal to 0 and solve. Okay, so what does that mean for the y-intercept? Set x equal to 0 and solve, right? Okay, so it's opposite, remember that, okay? So now since you have done some graphing on MLP, you again know this already. So the xy plane on the MLP does not contain any fractions, okay? So you have seen that, right? Okay, so what does that mean? If you get a fraction as either or both intercepts, you cannot use them. So what do you do when you get a fraction? When you get a fraction, find another point. Find another point by plugging in some small number to x or y, okay, until you don't get a fraction for the other intercept, okay? So again, like we have seen this scheme in section whatever, 2.1 or something. So I'm not emphasizing this too much because again, if you are not getting any fractions for x and y intercepts, you're good because that's how many points you need, the 2 points. But if you get a fraction, then you cannot use it, so you have to find another point, okay? And now, some other things to mention. The slope, okay, the definition of the slope. So the slope of a line passing through the 2 points, x1, y1, and x2, y2, okay, is, so first of all, the informal definition of the slope is, have you heard about rise over run before? Does it sound familiar? Yeah. Okay, so now rise means what? The vertical motion, right? Okay. So what does the vertical motion mean? The y, right? Okay, and now what about the run part? So yeah, you can run vertically, but like on the earth, you can only run left or right, right? You cannot run to like 300 feet, okay? Yeah, then you are not a human, right? So the run means x, right? Okay, so now, what does that mean in terms of these 2 points, x1, y1, and x2, y2? So now, by the way, do you remember the definition of the slope in terms of these 2 points?
Is it y2 minus y1 over x2 minus y2 or x1?
Okay, so y2 minus y1 over x2 minus x1, yes. Now, can we swap y1 and y2? In other words, into y1 minus y2. And if so, can we swap x1 and x2? And if so, are these 2 fractions the same? And the answer is, unfortunately, yes. Okay, so the order of subtraction does not matter. Okay, so you can do y2 minus y1 or y1 minus y2, either way. But what is the thing you have to be careful with? The bottom has to keep the same order of subtraction at the top, right? Or as how the top is subtracted, right? Okay, so what you cannot do is y2 minus y1 over x1 minus x2. Or even y1 minus y2 over x2 minus x1. You cannot do that. But as long as you maintain the order of subtraction, the order doesn't matter. Okay? So that is the definition of the slope formula. And now, the neat thing and the cool thing about this slope is by just looking at the value of the slope, we can immediately tell how the graph will look like. Okay, and hopefully you have seen this kind of scheme before. But can I go to the next page? Okay, so now the relationship between n and the shape of the graph. Okay, so part one, the positive slope. How does the line look like? The positive slope. So for example, like 4. So how does the line look like? It's an increasing line, right? Remember that? Okay, and now the negative slope. So negative slope means what? It's the opposite, right? Okay, so what does that mean? It's the decreasing line. And now the zero slope. Zero slope. How does the line look like?
Horizontal.
Horizontal line, yes. Okay, and now the last case, the slope is undefined. Okay, now some people think slope is undefined is same thing as the slope is equal to 0, but undefined means there's no value. Okay, so no slope means the graph is a vertical line. Okay, so hopefully you have seen these, especially the last two cases before. Okay, so the undefined slope means the vertical line. Okay, now, by the way, do you remember the general form of the horizontal and vertical lines? So first of all, the horizontal line means y equals the number. Remember that? Which means what? The x is missing, right? Now, what is the general form of the vertical line? So the horizontal line and the vertical line are opposites. So I guess you have to think, what is the opposite of that?
Is it just y equals m?
Uh-uh.
Oh, no,
Well, so what's the opposite of y?
x.
Yeah, so x equals the number. Okay. So y equals the number, which means there's no x. That's the horizontal line. And x equals the number, which means there's no y. That's the vertical line. Okay. So now let's look at a few problems. Okay. So find the slope of the line passing through the given points. Okay, so now here, surprisingly, there can be lots of algebra mistakes, and you'll see why. So here, most people end up labeling like this, x1, y1, and x2, y2. Okay, and now find the slope. So what does that mean? y1 minus y2 over x1 minus x2, or the other way, right? Okay, so now what is the top of the slope? Like in a fraction, what is the numerator? So if you feel comfortable with doing y2 minus y1, you can use it. Okay, that's fine. So it doesn't really matter, right? So what is the numerator of the slope?
-12.
Okay, so -7 minus 5, right? Okay. Now, what should be the denominator then?
5. minus -3.
5 minus -3, right? Yeah, not 5 minus 3, right? Okay, so it's -12 over 8, yes. And now, is that the answer? No, and why not? Because we can reduce it, right? Okay, so what's the answer? -3/2, right? Okay, so don't forget to reduce the fraction at the end. And now, part B, 2, 5 and -1, 5. Okay, so now, what is the top of the slope, the numerator?
Five minus 5.
And what's the bottom?
-1 minus 2.
Okay, so it's 0 over -3. What is 0 over -3? Is it 0 or undefined or -3? Now you have a third of the chance to get it right. So, what is 0 over -3?
0.
0. Got it right. Okay, so remember 0 at the top means 0. And now the part C. So here what can we do? 1 minus -4 over 3 minus 3, right? Okay, so now here I'm doing y1 minus y2. Okay, so now what does this mean? 5 over 0, right? And now what is 5 over 0?
Undefined.
Undefined, yes. Okay. So 0 at the top means 0. 0 at the bottom, undefined. Okay. So that is the slope problem. And now the main thing in the section is in the next two problems. Okay, so now a few more comments before we do the next two problems. To find the slope from the equation, isolate y. Okay, what's the reason? Because isolating y means what? Y equals mx plus b, right? Okay, so once y is isolated, what's in front of x will be the slope, right? Okay, and by the way, what is the name of this representation? Slope-intercept form, remember that? Okay. So once you isolate y, you can find the slope, right? And now, if you can, or if you want to graph a line, but you only know one point, okay? Now, some people ask, well, you just said earlier that we need 2 points, not 1 point, right? But if you are given a point, you'll be given something else. That is the slope. Okay, and if you know the slope, you can produce the second point. How? Use rise over run. Okay, so from this single point, you use the rise over run to come up with the second point, and then you'll have the 2 points which you can sketch the graph. Okay, so I am not saying we only need 1 point to sketch the line. We need 2 points, but sometimes one of them will be hidden. Okay, and now other than the slope-intercept form, what's also popular is point slope. Have you heard about that before? Now, what does it say? The equation of a line with slope m and it passes x1, y1. Okay, So this x1 comma y1 is just some random point. And now, do you remember how this point slope form looks like? Because normally people can remember this. Which is why they need some kind of hint. So y minus y1 is the left-hand side. And can you remember what goes on the other side?
X minus x1.
Okay, x minus x1. Now, where does m have to go? There has to be m.
In front of the x.
In front of everything, yes. Okay, so in front of x minus x1. Okay, and now here in this point slope form, what are the unknowns? X and y are not the unknowns, right? Because they will be part of the answer. So rather, what are the unknowns? These three, right? Okay, because they will be given or can be deduced from the problems. Okay, so these are the unknowns. Okay, not y and x. Okay. Anyways, so now let's look at the next two problems. So for each, find the slope, and rewrite using the function notation f of x, and then sketch the graph. Okay, so now let's start with part one. Find the slope. So what do we have to do here? To find the slope, we have to express it in terms of what? Y equals mx plus b, right? And what does that mean? Isolate y, right? Okay, so here, how do you isolate y?
Divide by -2.
Divide by -2, right? Yes. Okay, so divide by -2. So what do you get? Y equals -3 over 2x, right? Or 3x over -2, which is same thing as -3/2 x, right? Okay, so can you see the slope from here? What's the slope?
-3/2.
-3/2, yes, right? Sometimes people say slope is equal to -3/2 x, but remember slope is the value, it's a number, right? So it shouldn't have any x or variable. Okay, and now part number two, rewrite using the function notation f of x. Okay, now so many people, surprisingly, they think this problem is really tricky. But remember, this is really simple. Why? Because f of x is same thing as what? The y, right? So what do you have to do?
Just replace y with f of x.
Yeah, replace y by f of x. From where? Right here. Okay, so what's the answer? F of x equals -3/2 x. That's it. Okay, so many people, surprisingly, they think too much and too deep, and they kind of produce some bizarre answers, but no, just replace y by f of x, that's all. Done. Okay, and now graph. Oops, graph. So now remember, to graph a line, we need 2 points, right? Remember that? Yeah. Okay, so now mostly remember x and y intercepts will work, right? Okay, so let's find the x-intercept. Okay, so now how do you find the x-intercept? Set y equal to 0, right? Okay, so now when you set y equal to 0, okay, so now here you can set y equal to 0 from this form or at the beginning. Okay, it doesn't matter. But no matter what do you get? 0 equals what? -3/2 x, right? And now what do? Divide by -3/2, right? Okay, so these two numbers cancel here. And now, what is 0 over -3/2?
0.
0, right? Yeah, okay. So x is equal to 0, so what does that mean? It has 0, 0 as the x-intercept. Now, can we use this point? And yes, what's the reason? Because there's no fraction, right? Okay, so we can use this point. And now, the y-intercept. Okay, so now how do you find the y-intercept? Set x to 0, right? Okay, now when you set x to 0 from here, what do you get for y?
Zero.
Also 0, right? Okay, so what do you get? 0, comma 0. And now can you use this point? And the answer is yes and no. Yes, because there's no fraction, but no because of what?
It's the same as
Same as before. Yeah, right? Okay, so you cannot really use it. So at this point, you only know what? 1 point, right? So what does that mean? You have to find the third point. Okay, you must find the third point. So what do? You plug in a number, right? Some easy number to x, okay? Now remember, your goal is to not see a fraction. So from this y equals -3 over 2x, what can you plug into x so that you don't see a fraction for y?
3.
3 for x. So when you plug in 3 here, what do you get? -9 over 2. So there's a fraction. So you have to somehow remove this fraction -3 over 2, right? So what can you plug into x?
2.
2, yes. Okay, now when you plug in 2, what do you get? Just -3, right? Okay, so when x is equal to 2, you get y is equal to -3. So what does that mean? The ordered pair is what? 2 comma -3, right? Okay, which is another nice point. So sketch the graph. So 2 comma -3, so 1, 2, 3 down. So somewhere here, and then here is the 0, 0. So how does the graph look like? It's a decreasing line, right? Like this. Okay. So even when the x and y intercepts are the same, you have to find the third point. Okay, so now that is A, and then part B. Part B, 2x minus 5y equals 10. Okay, so find the slope is the first step. So what does that mean? We have to isolate y, right? Okay, now in order to isolate y, we have to do 2 steps. What are they?
Subtract 2x and divide by -5.
Right, so minus 2x. And then we have -5y equals -2x plus 10, and then divide by -5. So we get y equals -2x plus 10 all over -5, right? Okay, now this is, okay, so here y is isolated, but what's the problem? It's not in mx plus b, right? So what do we do here? First, yes, split, right? Yes, okay, like this. And then we simplify, right? So what do you get? Y is equal to 2 over 5x minus 2, right? Okay, so what's the slope?
Two over 5.
2 over 5, right? Yes. Okay, so the slope is 2 over 5. Okay, and now rewrite using the function notation f of x. So again, that's not a tricky problem at all, right? It's pretty easy. So replace y by f of x from where? Here, right? Okay, so what do you get? F of x is equal to 2 over 5x minus 2. That's it. Okay, and now graph. Okay, so remember we have to find the x and y intercepts. So first one, x-intercept. So we said y equal to 0. Okay, so now set y equal to 0. So what do you get? So you get what? 0 equals 2 over 5x minus 2, right? Okay, and now how do you solve for x from here?
Add 2.
And
Divide by 2/5.
right, divide by 2/5. Okay, and now how do you simplify 2 over 2/5? So we have seen this kind of fraction before, maybe once. Do you remember how to simplify?
Multiply by 5/2.
Right? So this means 5 over 2 times 2, right? Yes. Okay, and what does that mean? It's equal to 5, right? Okay, so what is the x-intercept? 5, 0, right? And can we use this point? Yeah, right? And what's the reason? There's no fraction, right? Okay, so we can use it. And now the y-intercept. So y-intercept means what? Set x to 0, right? Okay, so from here we set x to 0, so what's the value of y? Just -2, right? Okay, so it's pretty simple. So what's the y-intercept? 0, -2, right? And now can we use this point? Yeah. And do we have to come up with the third point this time? No. Why? Because these 2 points are different, right? Okay, and there are no fractions. So yeah, there's no need to find the third point. Okay, so now plot these 2 points. So 5, 0. So 1, 2, 3, 4, 5. And then 0, -2 is somewhere here, right? So can you see the shape of the line from these 2 points? Something like that, right? Okay, so it's an increasing line. Okay. Any questions on these 2 problems? So it's fairly simple, right? It's just tedious, basically. Okay, so now, next page. So for each, find the equation of the line in slope-intercept form using the function notation and graph the line passing through the given point and the slope. Okay, now this problem looks really complicated, but actually it's not too terrible because there are only 2 parts. Number 1, you have to write an equation of the line, and then number 2, you have to graph it. Okay, so let's start with the part 1. So find the equation in slope-intercept form. Okay, so what can we do here? So for part A, it's actually pretty simple. Can you see the equation in slope-intercept form right away? What's the equation?
Y equals 3x plus minus 6.
Right, so y equals 3x plus negative 6, which is 3x minus 6. And why is it so simple? Because that is the y-intercept, right? Okay, so 0, negative 6 was the y-intercept, so it's just y equals 3x minus 6. And now, use the function notation. So what does that mean?
Just change y to f of x.
Yeah, right? So it's that. Okay, and now, graph the line passing through this point with the slope. Okay, so now remember, here, we only know one point, right? Okay, so we have to use the slope to come up with the second point. Okay, so now let's see what that slope 3 represents. And can you express 3 in terms of a fraction?
3/1.
3/1, yes. Okay, now remember we will use rise over 1, right? Okay, so what does 3/1 represent? So what does 1 represent, basically?
How far you're moving horizontally.
Yeah, so horizontally means you can go either left or right. So which one is it?
Right.
Okay, so right 1. And what about that 3? What does it mean?
Up 3.
Up 3, yes. Okay, now, can you go left 1? Yeah. Then where do you have to go?
Down 3.
Down 3, right? Yes. Okay. Because this means plus 3 over plus 1, and this means negative 3 over negative 1, right? Both of which are the same thing as positive 3, right? Okay. So it doesn't matter which motion you take. So which motion do you want to choose? The right one and up 3 or left one and down 3?
Right 1 and up 3.
Okay, so here is the 0, negative 6. Okay, right there. And now you go right 1. Okay, something like this. And then you go up 3. Where are you? So where is the final destination? What comma what?
1 comma negative 3.
1 comma negative 3, right? Yes. Okay. So that is the second point. And you can just connect these 2 points, and here's the graph. Okay. Now, if you chose the left 1 and down 3, you'll be end up somewhere down here, right? Okay, which is a different point, but you still get the same graph. Okay, but most people choose the first one because there's no negative. Okay, and now part B. So this one can be a little bit tricky. Negative 2 comma negative 3 is the point, and the slope is negative 4/3. Now, is the answer for part 1, which was this one, equal to y equals negative 4/3 x minus 3? No. And this time, what's the problem? That's not the y-intercept, right? Okay. So to write the equation, here is my suggestion. Start from the point slope. Okay. Now, what some people do is, well, you said we have to express the answer in slope-intercept, but why do you use point slope? Well, we are just starting from the point slope, but we will end up with the slope-intercept, yes. Now, Remember for the point slope, where was it? On the previous page? Yeah. What were the unknowns? X1, Y1, and M, right? From here, in this problem, do we know X1, Y1, and M? Yes. That's X1 and that's Y1, right? And that's M, right? Okay. So what do? Y minus Y1, so that then means what? Y minus -3, right? Okay, be careful, it's not Y minus 3, right? It's Y minus -3. N is equal to M, which is -4/3. And then parentheses. And then what's next? X minus X1, right? And what does that mean? X minus -2, right? Okay, and you just have to simplify this. So what does this mean? Y plus 3 is equal to -4/3 times X plus 2, right? And now, how do you go from here to the slope intercept? So slope intercept means what? Y is by itself, right? Okay, so what do you have to do? -3, right? Okay, and now one more thing that we have to do. So in the slope intercept, remember, it's y equals mx plus b, which means what? We don't see any parentheses, right? So what do you have to do? That, right? Distribute to -4/3. Okay, so what do we get? Y equals -4/3 x. Okay, so that's pretty simple. And now, -4/3 times 2. What's that equal to? Okay, so don't worry about -3 here. -4/3 times 2.
-8/3.
-8/3, right? So it's -8/3 minus 3. And now, what is -8/3 minus 3?
-5/3.
Be careful. 3/1. Does it remind you anything?
LCD.
LCD. And what is the LCD?
3.
3, right? Yeah. So times 3 times 3. So what do you get? Negative
1/3.
1/3? It's -8 minus 9, right?
Oh.
So negative
17.
17/3, right? Okay, yeah, be careful. -17/3. What is that? Okay, -17/3. Okay, and now, what do we do finally? Replace y by f of x. So f of x is equal to -4/3 minus 17/3. Yeah, fraction is awful, but you have to somehow remember how to do the fraction calculations. Yeah. Okay, so now, graph. So what does that mean? We have to use this slope -4/3, right? And now, what does this mean, -4/3? Go where by how many units?
And that'd be down 4.
Okay, down 4. And then? Then what about 3? What does 3 represent?
Right 3.
Right 3, right? Yeah, it's not left 3 because if it were, we would have what? Negative 4 over negative 3, right? Which is positive 4/3. But down 4 and right 3 means negative 4 over 3, which is still negative sign. Or can we go left? Oh, I'm sorry, down, up 4. Yeah, then where do we have to go? Left 3, right? Okay, then here we have plus 4 over negative 3, right? Which is still negative 4/3. Okay, now which motion do you want to take?
Up 4 and left 3.
Okay, so this one. So we start from negative 2, negative 3. So here is negative 2 and here is negative 3. Now up 4. So up 4 means somewhere here, right? Or maybe somewhere here. Up 4. And then go left 3. So that means left 3. Maybe like that. Okay. So now, where is the final destination? So that's negative 2, negative 3. And then we go up 4 and then left 3. So what are the coordinates of the final destination?
1, -5.
1, 5. Okay, now where is the negative sign?
No, 1, -5.
Okay, now be careful. It's negative 5, comma 1, right? Yes.
Oh, yeah.
Yeah, okay. So that's the final destination. Yes. Okay, so the graph looks like this. Okay, and of course, if you chose down 4 and right 3, you'll be somewhere here, right? Okay, which is a different point, but you still get the same graph. Okay, and now 2 more problems. So now we keep the same point, but the slope is equal to 0. Oh, slope is equal to 0. Do we know the graph when the slope is equal to 0? How does the graph look like?
Horizontal line.
Horizontal line, yes. Okay, so let's remember that. So now, find the equation. So again, let's start from the point slope. Okay, so we have what? Y minus negative 3. Okay, so I'm just imitating what we have done before. And then the slope is equal to 0 times x minus negative 2. Okay, so now we have to rewrite this. So y plus 3 is equal to, what is the right-hand side? 0 times x minus negative 2.
Just +2.
This whole thing. Remember, it's 0 times something. What is 0 times something? What is 0 times anything?
0.
Yeah. Okay, so this whole thing is equal to 0. So y plus 3 is equal to 0. So what does that mean? Y is equal to negative 3, right? Okay. And now replace y by f of x. So what do you get? F of x is equal to negative 3, right? Okay. So that's all. And now graph. So we know that the graph is a horizontal line and it passes -2, -3, which is right there. Okay, so what is the only option for the graph? That, right? That has to be the graph. Now, give me another point on this horizontal line by just looking at the graph.
0, -3.
0, -3, yeah, which is right there, right? Okay, so it's really obvious based on the graph. And now part D, so still same point, but the slope is undefined. How does the graph look like?
Vertical line.
Vertical line, right? Yes. Okay. So now let's try to express the equation of this line. So what do? Y minus -3 is equal to, oh, the slope is undefined. So it's undefined times x minus -2. So what do? Y plus 3 is equal to undefined times x plus 2. So you distribute to undefined. So what? Y equals undefined x. Undefined x plus undefined 2 minus 3 or something? Is it something weird here? Yeah. What is this? Okay. So this looks terrible. So this is kind of bad approach. Now, go back to this page here. Any vertical line has the form x equals the number. Okay, so what does that mean? It has to have x equals some number, right? Can you guess what that number should be?
-2.
-2, yes. Okay, now, is this same thing as f of x is equal to -2? Okay, now, let's sketch the graph, okay? And then I'll answer this question in a minute. Now, the graph is a vertical line and it passes -2, -3. So what is the only graph? That, right? Okay, so that's the only graph. And now on this vertical line, give me another point.
0, -2.
Be careful. It's not 0, -2. 0, -2 is here.
-2, 0.
Yeah, -2, 0, right? Okay, so now that's the graph. And now, is this a function? No. Why? Because it fails the vertical line test, right? And which vertical line? Just exactly the same vertical line, right? Okay, so it's not a function. So what does that mean? We cannot use the function notation here. And remember, f of x is same thing as y, right? Not x. So it's just x equals -2. And we cannot use function notation because it's not a function. Okay, any questions over these problems? Okay, so it's kind of long and tedious a little bit. Okay, so now the last thing in the section is this, the average rate of change. Now, for a function f of x, the average rate of change over the x interval a comma b is given by f of b minus f of a over b minus a. And alternately, we can write f of a minus f of b over a minus b as well. So that's the average rate of change. And now, does this definition look familiar? Have we seen something like this before?
Isn't that similar to x1 minus, or y1 minus y2 is equal to x1 minus x2?
And what's the name of the definition?
So,
The slope, yes. So what does it mean? Average rate of change and the slope, they are the same. Okay, so people can ask, well, then why do we define this once more? Because we have already defined the slope before, yes. The difference in average rate of change is we typically see this thing in word problems. Okay, now so far we haven't done any word problems in this section, but now we will do word problems. Okay, and also this average rate of change has the unit at the end. And the unit is whatever the y unit is, you write that first and then per x unit. Okay, so it's basically y per x, basically. Okay. And now, have you seen this something per something unit before? Yeah, it's really popular. And where do you see something per something unit in our real lives? In the car. And where do you see something per something?
miles per gallon?
Miles per gallon, yeah. And another one, miles per hour. Okay, so this something per something is actually quite closer to us than what we might think. Okay, so let's look at these two problems. Find and interpret the average rate of change for the function below. Okay, so the percent of pay raise. Okay, so here we have x and y axis, but they have the names, right? So the y-axis has the name of what? Percent of pay raise, right? And then the x-axis is the ER, right? Okay, and now remember the average rate of change is same thing as the slope. Can you see the slope of this function?
0.
0. And why? That's the horizontal line, right? Okay, so the slope is equal to 0. Okay, because of the horizontal line. Horizontal line. Okay, now remember for the average rate of change, it has to have the unit. So what is the unit? It's y unit per x, right? And what was the y unit? Percent of pay raise. And then per x unit, which is ER, right? Okay, so the answer is 0% of pay raise per ER. Okay, so that's the average rate of change. But what does this even mean?
There's no pay raise.
There is a pay raise because if you look at the graph, it's been constant as what? 3% of pay raise, right? But what is constant here? The change in the pay raise is constant, right? Okay, so after the first year, it's still 3%. Second year, 3%. Okay, so it means the change in the percent of pay raise is constant. over the years, right? Okay, so the percent of pay raise is basically constant, but its change is 0. Okay, change is 0 does not mean there's no pay raise, right? There is a pay raise, but there's no change, basically. Okay, so that's what it means. Okay, so now this was kind of a boring problem, I should say. So let's do not quite boring problem, which is the next one and the last problem of the section. So in 2010, there was a guy, Henry. Now, by the way, that's not me, right? Because I have Y as the last syllable. When I went to DC several years ago, I met a guy because like he was our guide for the tour. And his name was Henry with that I as the last syllable. And the cool thing was he was at that time a TCU student. And he was doing an internship at DC, like at the Capitol Hill. And I remember he said like he was about to graduate. But anyways, so yes, like I was Henry and like my tour guide was also Henry, like with the kind of different name, like different syllable. So anyways, that's not the point of the problem though. So maybe you can meet with like your, maybe like same pronunciation as your first name, but maybe it spells differently. So maybe you can meet that kind of person in the future. But in 2010, Henry spent $955 on a research in math. In 2013, the amount went down to $865. Assuming there was a linear relationship between the amount spent and the year, find and interpret the average rate of change. Okay, so now, so far, we had X and Y, and we need X and Y because our unit for average rate of change has to have Y per X, right? Now here, in this problem, do you see the two units going on? What are the two units that are being dealt in this problem?
Dollar spent in the year.
Right, money and the dollar, right? Yes, okay. So this and this are the two units. Okay, so what does that mean? Since our average rate of change has to have something per something, it has to be either dollar per year or year per dollar, right? It has to be one of these two, right? And now, this is kind of fairly straightforward. Which unit sounds better?
First one.
So first one, right? Yes. Okay, dollar per year sounds a whole lot better, right? Okay, so what does that mean? We can deduce the Y unit is dollar and X is the year, right? Because Y has to come first in the unit, right? Okay, so now, what do we do next? So now let's find the slope. Now here, even though we are not given a graph, can you still use the definition of the slope? Yes. What is the numerator of the slope?
$955 minus $865.
Okay, then what should be the denominator?
2010 minus 2013.
Right, 2010 minus 2013, right? Okay, so 955 minus 865, what is that, 90? And then divided by -3. And what is 90 over -3?
-30.
-30, right? Yes. Okay, and now that's the slope, and now attach the unit. So what's the unit? Dollar per year, right? So what does that mean? Negative $30 per year. Okay, so that's the answer. Now, what does this even mean? We know any money cannot have a negative value. So is this false? What does this even mean? Negative $30 per year.
You're spending negative $30 per year on research.
Right, so the negative means what? Increase or decrease?
Decrease.
Decrease, right? Yes. Okay, so this means the amount spent on a research in math, basically, but I'm not going to write that. The amount spent was decreased. Okay, now it's not just random decrease, right? There's a fixed rate. Decreased by $30 per year. That's what it means, right? Okay, and now here, why don't I write the negative $30? Because the negative sign has been taken care of where? The decreased part, right? Now, what if we got a positive $30 per year? Then we will say the amount was increased by $30 per year, right? Okay, yeah. So that's what the average rate of change means. Okay, so any questions over these problems? Okay, so that's the end of 2.4. And now let me briefly start 2.6. Okay, obviously we cannot finish it. So now 2.6, we will be talking about the graphs of basic functions, but it's actually, so the title is kind of misleading because the main core of the section is not the graphs of basic functions, although we'll see graphs. But let's start with the first thing first. So the continuity. So f of x is said to be continuous over the x interval if there is no break, jump, or empty holes on the graph. Okay, so now these three words may sound confusing. So here are some illustrations. Break means there's a break like that. Okay, so it's supposed to be a line, but somehow in the middle there's a break. And now jump means here's a line and here's the second line. And then there's this big jump right there. And then empty hole means something like this. Okay, now the graph should not observe any of these phenomenons so that we can say that the graph is continuous. Okay, so basically what does continuous mean? The graph looks very smooth and nice. And if it's not continuous, we say it's discontinuous. Okay, so it's fairly obvious. And now let's look at these basic, or like two problems. Describe the interval of continuity for, and now you'll see that there's this like huge blank, right? Because I'll write down the two graphs. So part A. Okay, and here's the empty hole here. Okay, so here's the first graph. So it is what? The almost parabola, right? The almost U. Okay, and that point is -2, this point is 2, and this point is equal to 3. So now, as a whole, this graph is not continuous. Do you see that? Because of why? That one, right? Empty hole. However, does some portion satisfy the conditions of continuity? Okay, not everything, but some portions of the graph. Yes, so let's look at this portion here. Okay, this portion. So that's continuous, right? Because there's no break or jump or empty hole. Okay, so now how do we describe the interval of continuity for this portion? We have to look at what? The x values. Okay, so what is the minimum and the maximum x for this left branch or left curve? What is the minimum x?
Negative infinity.
Negative infinity, yes. And what is the maximum x?
3.
Be careful, x value. 3 is what? So
0.
y? Huh?
0.
0, right? Yes. Okay. So why did I give negative 2, 2, and 3? Oh, you know why. To trick you, right? Yeah. So don't be falling into those 3 traps. Okay. We only look at the x values. So what's the interval notation? Negative infinity, comma 0, right? Okay. And now what are the symbols? Parentheses here. And what's the symbol around 0?
Parentheses again.
Also parentheses, yes. Okay. And now, similarly, look at the other branch, which is this one. That's also continuous, right? What is the minimum x and maximum x for this right curve?
0.
And
Infinity.
infinity, right? And what are the symbols?
The same.
Same, right? All parentheses, right? Okay, so how do we combine these two intervals? Put the U symbol in between, right? Okay, so that is the region of continuity. Okay, again, in other words, negative infinity, comma 0, union 0, comma infinity. Okay, so that is the answer. So everything but 0 is the continuous region. Okay. And now part B, okay, and then that will be it for the day. So part B. So the graph looks like this. Okay, so it has the W-shaped graph. Okay, so now, where is this graph continuous? So in other words, what do we need to check? Is there any break or jump or empty holes on this graph? Is there any break on this graph?
No.
No. Is there any jump on this graph?
Yes.
Where? Where's the jump?
Where it goes from decreasing to increasing.
Well, jump means like really like a gap jump, like that. So there's a gap here, and then you go into the second graph. So there is no jump here, right? Is there any empty hole? No. So where is this graph continuous?
The whole thing.
Everywhere, yes. Okay. So it's continuous everywhere. Okay. So yes, people are bothered by these sharp points right there. But remember, sharp points is okay, right? Because that's not part of the continuity. Okay, so these 3 points, even though they are transition points, they are fine. Okay, as long as your graph doesn't have any break, jump, or empty holes, you're good to go. So what is the interval notation?
Negative infinity, comma infinity.
Yeah, everything. Okay. So any questions over these continuity problems? Okay, so tomorrow we will look at this library of basic graphs, okay, most of which is something that we have seen before. And then we will look at the main core of the section, which is called piecewise function. And then we will go to 3.1, okay? So I don't think it will take a long time to finish everything. So I will stick to the current exam 2 date, which is supposed to be this Wednesday, okay? And then I will post the second extra credit homework sometime this afternoon, okay? And that will be due this Wednesday as well, okay? So that's it for the day, and I'll see you tomorrow.